All right, we are back in action. Sorry about that. My real life needed me. Now my other real life is starting over again. Okay, so what I was saying is that we have to find the value of this constant, which goes at the end. And if x plus 3 is a factor, then when I plug in -3, my remainder should be 0. Think that through. If x plus 3 is a factor, then -3 is a 0, and that means there will be no remainder. So let's use our big brains to figure out what that would have to be. So I drop my 2, I get my -6. I get a -1 and a 3. I get a -3 and a 9. Knowing that this column has to turn into a 0, the only value of D that will make that happen is if it's a -9 up in here. So my function would have had to be 2x cubed plus 5x squared minus 6x minus 9 in order for x plus 3 to be a factor. That's kind of fun, and that's something I would put a little star next to and make sure I know how to do, if you catch my drift. All right. This is so many things. Good thing it's easy. Determine end behavior. All right. So I'll be looking just at this part. Let's do that first. So this is negative. So that means my right end is going to go down. They're probably looking for you to write false here, or at least think of it in terms of that. And then because this is odd, they are opposite. So my left end's going to go up, and so this left end rises. The answer spots for these are weirdly backwards. Alrighty, here this is a +1, so my right end's going to go up. So that rises, even though that looks like some word that's not actually a word. And then this is odd, so they're opposite. Left is going to fall. And here I have a negative leading coefficient, so the right end is going to fall. And this is even, so they're going to do the same thing like they would in a parabola. And so that means the left end is going to fall also. All right, so then does it rise or fall? Okay, we already figured that out. Factor to find all the zeros. Okay, well, if they're telling me to factor, that means it's factorable. When I'm looking at my original function, I need to see if there's a gotta check first, a greatest common factor. So I'm going to pull out the negative, the 3, and an x to the 3rd, because that's the most I can take out, because this one at the end would be limited and not be able to give any more of those. Leaving me with, if I divide each of these pieces by 3x cubed, or I should say -3x cubed, I'm dividing that out of each. I'm just going to have a positive x to the 2nd, then a positive 3x, and then a -4. And then that's supposed to factor further. So this is out in front. Then I need a way to get 4 that subtracts to be 3. So my options for 4 are 1 and 4 or 2 and 2, but the only ones that subtract to be 3 would be a 4 and a 1. Since I need to have a positive 3, I need to have a positive 4 and a -1. So if I'm going to list my factors, they are going to be -3x cubed, then x minus 1, and then x plus 4. If I'm going to think of my zeros, and it does say to determine the multiplicity, I'm going to have from this factor, I'm going to get a 0 of 0, and it's going to have a multiplicity of 3, which is odd, so that one's going to snake across here. The next factor, x minus 1, is going to give me a 0 of 1 with nothing funky monkey going on because it doesn't have a power, so it's not got multiplicity. And then my last factor of x plus 4 is going to give me another 0 at negative 1, 2, 3, 4. Okay, so both of these are going to cross here and here and then kind of snake across in the middle. And we already determined the end behavior up here. The right end falls and the left end goes up. So then this is going to be kind of coming down here. And then the left end is going to be going up. So it says to sketch. So I'm not really responsible for a bunch of stuff being perfect, except that this is going up, comes down through here, kind of snakes weird through here, and then comes back down. And you know what? Do the best you can with that snaking across. I'm terrible at it. So me expecting you to be perfect at it would not be very fair. So again, if they're telling me to factor it, then it must factor. So let's take out whatever the greatest common factor is, and it appears that that would be x to the 5th, leaving me with x squared minus 6x plus 9, just plain 9. So that's going to leave me with needing 9 in a way that adds up to 6. So I'm going to need to use 3 and 3. For it to be negative 6, I'm going to have to do that. So when you write out the factors, like if you wrote this function in, if what it asked you to do is write the function in factor form, you would write the f of x equals, and then you would have this written with that power indicating that that got repeated twice. If you're just listing the factors, you have this factor, this factor, this factor, or you can write it like that. When you are looking at the zeros, whether you were asked to give the zeros or just draw, you're going to have a 0 from this x to the 5th, and that's going to have a multiplicity of 5, which is odd, and therefore that is going to snake across at that spot. And then you're going to have x minus 3, which generates a 0 of 3, and because it has a multiplicity that's even, a multiplicity of 2, that is going to just bounce off the graph at 1, 2, 3. So we're using all the information we know from up above. Right end up, left end down. So as it comes up, it kind of snakes across, and then it has to just bounce here because this has an even multiplicity and goes back up. So it's a sketch. Things that have to be perfect or, you know, like that you should know would be that this is going to just bounce off here and go up. Here, you're going to do your best to squiggle across there and go on down, and then this is just sort of the best you can do. Last but not least, in that same vein, this one is asking me to do the same thing, so I need to factor it. So I'm pulling out my greatest common factor, so I'm going to get rid of the negative. I never want a negative in the front, so whenever I'm factoring, hint, hint, pay attention, get that negative out of there. So pull out a negative 5x to the 2nd, because that's the most this can give. If I divide each term by that negative 5x squared, I'm just going to have an x squared left. And here I'm going to have a negative 4. This is probably the favorite kind of factoring to forget to do anything further with. And it's called the difference of two squares, because it's the difference of two perfect squares. This is the square of x. This is the square of 2. So my factors, it's not asking me to write the equation or I'd write an equal sign, but it's asking me to tell the factors. One is negative 5x squared, and then this breaks into the sum and the difference of that x and 2. That is not multiplicity because it's not repeated. This is going to generate a 0 of 0. With multiplicity 2, so that's even, so it's going to bounce there. This is going to create a 0 at negative 2 and then again at positive 2, but those do not have multiplicity, so they're just going to zip on through. Looking up at what I found earlier, my right is going to fall, and I don't know why I did that. My right end's going to fall. Thank you. And so is the left. So those are the things I know for certain. So it's going to come up here, bounce off here, and then come back down like an M for mathematics. Don't know exactly how high that each of those maximums goes, but I can't really know that, so do the best I can. Good life skill. Do the best you can. Okay, if it says to use the intermediate value theorem, you want to think about what that means. It says, what is the least number of zeros that it has to have? Zeros occur where there's a sign change in the value, in the y value. This is telling me the value. This is telling me the location. So I'm cruising around at positive numbers, but right here it goes from positive to negative. So that's going to be 1, 0. Then I'm cruising around below the x-axis until right here where it pops back up to the positive. And then I keep on being positive until right here where it goes back down. So there are 3 places where it changes, and by it, I mean the y value changes from positive to negative or vice versa. And so that means I'm going to have 3 zeros at least, because that's just showing this part of the chart. Between what 2 consecutive integers, so this is asking me for x's, must the value of the function be 15? Okay, well, take a look at it. I'm looking for 2 numbers, one bigger and one smaller than 15. This appears to be the only place. If you are at a y value of 21 and you're cruising down to a y value of 5, you will at some point hit 15. So that is going to mean that somewhere between the 2 consecutive integers, -4 and -3, you are going to hit a y value of 15. That's just conceptually the intermediate value theorem. Find all zeros. Pay attention to what they're asking. Find all zeros, given that this is one of the factors. Okie dokie. Again, I really like to think about the factors and the zeros. I keep in mind that they just gave me that x plus 4 is a factor, meaning -4 is a 0. Since it says find all zeros, I'm writing that down before I forget. The given one is typical to forget. Looking at my degree, I'm going to have 3 of them, which doesn't surprise me because there's 3 little lines. So what do? I have to get to a quadratic so I can factor it. And so I take the fact that I know one of my zeros, I throw the 0 in the box, and then I do synthetic division. 4x cubed, 9x squared, -30x, -8. I do not have any places where I needed a 0. I drop this 4, I get -16. So then I'm at -7, which turns into +28. So that's -2, which turns into +8, which is a 0, and really not very surprising. For lack of space, this went from an x cubed down to an x squared because it always goes down by 1. So I'm at 4x squared minus 7x minus 2 according to this bottom row. I don't know any other zeros, so I can't do anything more. I'm going to have to factor to find out where this equals 0. I'm going to use my little cheaty way and write a 4x here and here. I'm going to be thinking about 8 in a way that subtracts to be 7. So 8 and 1. I need a -7, so -8, +1. Since I inflated them, at least one of these has to reduce, and it's going to be this one. So my other factors are going to be, this is so messy over here and not enough space. So my first factor was x plus 4. Maybe it'll write better here and show up a little better. And then I just found another factor of 4x plus 1. And my last one of this, once it's reduced, is x minus 2. So that'll generate a 0 at 2 and -1/4. So don't mess around with the word all. If it says all, it means all. And that means including the one that was given. All right. Again, just understand the relationship. If this is a 0, what is a factor? So it's back to thinking about that factor 0 table that I keep insisting is a brilliant idea. So I'm thinking about if they give me this as a 0, I got to work backwards. And that's going to get me back to 3x plus 2 as a factor. because 3x plus 2 will equal 0 when I subtract the 2 and then divide by the 3. So you have to do some backwards thinking to get to that factor. The last two are kind of big brain applications of things that you learned. When p of x is divided by a linear factor, x plus 2, the quotient, meaning the answer, has a degree of 5. The remainder is 7. So these are conceptual questions. Okay, the quotient is your answer. You divided by x plus 2. If you're dividing by x plus 2, would you use synthetic division or long division? I would use synthetic. And it's saying that when you're done, you have a degree of 5. So like this row that you get would have a degree of 5. So then think about what the row you started with would have to be. So the original p of x would have to have a degree of 6, because if you started with x to the 6th power, you divided it by x plus 2, you're going to end up with the degree of 5 that they're talking about. It always goes down by 1. So if you're going backwards, you're kind of increasing it back to what it was before. This question, is x plus 2 a factor? Think about what that means. Factor means it went in evenly, and it means your remainder is 0. It says right here the remainder is 7. 7 is not 0. So that is a no. This is not a factor because the remainder equals 7, which does not equal 0. This one feels like something you don't know how to do because it doesn't give you the function and you don't need to find it. You're using your conceptual understanding of things like the remainder theorem. The remainder theorem basically was telling us, hey, you can find the value of a remainder by doing synthetic division, and it'll be the last little number here. And that's going to also equal the function's value when you plug in the number that was in the box for the division. So think about it. If they're telling you x plus 2 is what you're dividing by, the number in the box is going to be a negative 2. And so it's telling you when you do all your work, the remainder down here in the bottom right corner is a 7. And what we learned from the remainder theorem is that then the function's value at the number in the box, whatever you would be doing your synthetic division by, will equal that remainder value. So that's my remainder theorem. This number down here in the bottom corner of my synthetic division is the remainder. They told me it's 7, but it is also the function's value if you plug in the number from the box. So this problem, number 13, is a big brain conceptual problem. No real math, but it's conceptual, and that can sometimes be worse. So the dimension, finding the missing dimension. Okay, for the volume. Volume equals length times width times height. Well, we know the length. I think that this is the height. So then this is the mysterious width. It doesn't really matter which is which. What I know is that the volume's end result is my x cubed plus 7x squared minus 6x minus 72. And I'm trying to split that apart. And I know that these two go into it. So you're currently saying, well, I know that x plus 6 and x plus 4 in no particular order are my factors. So I also know that these two things are going to be my zeros. So I'm going to break this thing down to find the last one. I'm going to start with whichever one I want. It won't matter. 1x cubed, 7x squared, minus 6x, minus 72. I expect to get a 0 because they told, I can see from the picture, that x plus 4 and x plus 6 are part of this equation. They're probably the length and the height, so I'm looking for the width. So I drop my 1 and I start my process. Multiply, add, multiply, add. And then multiply. So not surprisingly, and makes me happy, that is a 0. It went in evenly. Then I keep going. I use this bottom number, the answers from the first round, to do my second round, and it doesn't matter which 0 I did first. I used the -6 first, could have done the -4 first. I drop the 1, and I start my process. This is -3, and I start my process. Not surprised to find that that went in evenly. Keeping in mind, for the billionth time, this goes down by a power of 1 each time. This bottom row that I have right now is actually just 1x minus 3, which at this level of math, we just call x minus 3. That gave me a remainder of 0 because x minus 3 goes into it evenly, meaning that the 0 that goes with that would be a 3. But the question was asking, what's this other dimension? And the answer is going to be x minus 3, because that's the missing piece. My volume came from x plus 6 times x plus 4 times a third dimension, which is no longer a mystery. And if you're finished early, since there's not a prize for being done first, if you're bored, you could go ahead and FOIL this all out and you should get that function. All right, that is the end of the review. There are a couple things I'm thinking that weren't on here, like vertex form of a polynomial, a quadratic. So that might be the only thing off the chart. But I'll look at the quiz again and see if that's something that you need to know, and then we can talk about it. But that should help you at least get through the review and hopefully have some clear understanding of it. This looks like a ton of work because you have a very big brain right now. You've learned so much stuff. You can know how to do all of this. That's impressive. All right, my friends, have a good night, day, morning, whatever you're watching this. Bye.